Okay, this question deals with geometry and most specifically the coordinate plane. So there's a lot packed into this, and it's not, I wouldn't say it's a tremendously difficult problem, but there are so many pieces and parts to it that you would need to know. And if you know just a little bit about each of those, then you can answer it. And I think as we go through it, you'll see what I mean. So geometry in general, just keep in mind that it's a way for people, I guess mathematicians, but really just people throughout history, trying to understand the real world around them. Just like an author would use words which are symbols to represent the world and describe things, and geometry was a way for people to describe things that they saw in the real world using a language that they developed that could describe it. If you wanted to know how tall something was or how far away it was, geometry was the way that you could do that without breaking out, a ruler or start, stepping 1, 2, 3, 4 for, 10 miles trying to figure out how far something is. It was a way to use symbols and concepts to figure out and describe the real world around them. And coordinate plane is one of those principles. So a plane, you could think of it like a piece of paper. If you had a piece of paper lying down on the desk in front of you, that would be a plane, a representation of a plane. The paper has a little bit of thickness, so in math, thickness is not part of a plane. It has 2 dimensions, so you have this dimension here and this dimension here. And if you were to pick that piece of paper up and put it on its edge and look at the paper, in the math world, you wouldn't be able to see that because there is no thickness to it. So we have 1 dimension, which you would see as a line. It has no dimension this direction or this direction. It's just left and right. So a line is typically what's used to describe 1 dimension. Also, you could think of as a point as 1 direction. Think of it this way: if you pick this line up and put it into that 3rd dimension, so you were looking straight at it, and then turned it back into 1 dimension, it would just be a point. Then there are the 2 dimensions. That's the left, right, up, down. And then there are 3 dimensions. So you still have your 1st dimension and 2nd dimension, but now you have this 3rd dimension, which would be another line coming out of the screen straight at you and behind the screen straight back. That's the 3rd dimension. That's depth. And then coordinate simply means putting that grid onto the plane, what you've come to know as X, Y coordinates, identifying all the points on the grid by using a number line, all these numbers on the X and the Y axis, and then every point in space having a coordinate that can be identified as an XY up-down coordinate system. And this is extremely valuable and is used. It's really almost the start of the digital age, is when the coordinate plane system came into being, and it's been around for a very long time. It's called the Cartesian coordinate system. You may have heard that. And all that means this is from the person who is typically credited with, I don't know if discovering is the right word, but it bears his name. He's a French guy named René Descartes. So you can see the word Cartesian comes from this cart part right here in his name. So that's all it is. It's just the Cartesian plane is not a thing in and of itself, like it pre-existed. It was just an idea that came into being of the grid system. And this René Descartes was credited with that, even though he probably didn't come up with it. But that's what we call it, is the Cartesian coordinate system. And you've seen it, obviously. It just looks like that. You have your X, Y, and the grid. And you've probably seen it your whole life in a lot of the things around us, your phone, your computer screen. If you ever use a drawing program like Photoshop or anything else, that's based on that same coordinate type system. If you even used an Etch-a-Sketch as a kid, that is the XY coordinate system. In fact, let me show you that. This is the Photoshop, and it's without any layers on top of it. It's got this one line, but these little dots in here are what they call pixels. They're just, it's part of the XY coordinate plane. So everything is on right angles, they're squares, and each of these dots or pixels has an identifying coordinate ID, just like your XY axis. And each one of those dots or pixels has dots and pixels inside of it. So if you continue to zoom in, you can't really tell what's happening here, but each one of those is being divided into 16 more on a coordinate system. And as you keep drilling down and down, you can see what's happening to the line. And when we get all the way to the very bottom magnification of this system, you can see that these little squares, these are pixels, but those pixels have little square pixels inside of them, and there's 16 of those. It's 4 by 4. And if you could go down another level of magnification, that pixel would have 16 pixels in it. So it just keeps going, drilling down and down and down, and you're going to find more of that applying as you go on in math, especially when it comes to plotting curves onto this Cartesian coordinate system. It becomes a factor. So I went out and found a picture of an Etch-a-Sketch. This has the little circle, the little wheels on it, and you turn them, and it moves the little drawing thing inside of it left and right, and it's being maneuvered around on a coordinate XY system. Let me show you. So if you broke open one of these Etch-a-Sketches, you can see right here, this is the vertical axis, and this is the horizontal axis. This X thing and the circle thing aren't really connected to this dot right here. But when you turn the knob, it moves the little drawer thing either up or down, left or right on this right-angled XY coordinate system. Here's just a little better angle of it. You can see the X and the Y coordinate axis coming right through. This would be, it depends on the orientation, but I think this would be the X, because there's one of the buttons, and if the other button's over here, I don't know, but one of the axes goes through this direction and one goes through this direction, and as you turn it, that little drawing stylus thing moves along this axis, that axis, up, down, left, right. All right, so that's enough of that.